When we look at a set of data, we can see sometimes there's a pattern. If we draw a histogram to represent the data, we can sometimes see a shape to the histogram that indicates certain things. So here's 4 examples of histograms, and they all have different types of shapes. And you can see for each one, or certainly for 3 of them, there's a certain pattern to the shape. There's arguably one that is fairly erratic. But different data can create different histograms and different shapes as a result. What we talk about is the distribution of the data. And we want to look here at whether a set of data might be symmetrical or whether it might have some skew. And a skew would occur if there's a certain leaning towards a certain set of values other than the center. So we'll go through first 3 different main types of shapes of distributions. So let's look at the skew first of all. You can have a set of skewed data. Now you can see here there's a brown histogram, and then there's a blue sort of curved shape that represents that shape in a more sort of smoothed out way. Whether you get it as a curve or whether you get it as a histogram, you can see that it looks a little bit symmetrical, but there's a bit of a tug, a pull in a certain direction. So you can see there's a tail dragging off to the left. That long tail is because there's extra values at the lower end of the scale. What this does is this drags the mean of a set of data to the left of the peak or the center or the mode of the distribution. The long tail has been dragged to the negative side of the peak, to the left side. The opposite of that would be a positive or right skew, and this is where your distribution has a drag of a long tail to the right, okay, to the positive side of the distribution. The mean, as a result, is dragged also to the right of the peak or the mode of the distribution. Now, if there's no skew one way or other, if it is therefore likely to be symmetrical, okay, and we sometimes talk about a bell curve, just meaning that sort of symmetrical shape. That bell curve can be, quite a flat one or quite a steep one. It can have very different shapes to the curve, but at the end of the day, it has a symmetry about it. Here's another example of the same sort of bell curve shape. There's a symmetry. Approximately half the values are either side of that middle peak, and that middle peak where the mode is the highest, the highest bar, highest point, the mean and the median is also at that point. The key thing is the mean is at the center. So in summary, you can have effectively 3 different types, general shapes of distribution. You can have your symmetrical shape where the mean is in the middle, or you can have a skew. And if you have a skew, you can have a left skew, a negative skew, and this is where the mean has been dragged and there's a tail to the left. Or you can have a positive skew where there's a drag to the right and the mean is also going to be to the right of that sort of highest mode point.